Hi, Miss Orteza here. Today, I'm discussing with you the 6 trigonometric functions on special right triangles. Let us review the Pythagorean theorem that says that the hypotenuse of a right triangle is found by getting the square root of a squared plus b squared. So let us apply it here in this special right triangle, which is the 45, 45, 90-degree triangle. And since these two angles are congruent, their opposite sides are also congruent. And we apply the Pythagorean theorem, we find the square root of 2 as its hypotenuse. The same way with the 30, 60, 90-degree triangle. This is the ratio of its sides, wherein the hypotenuse is 2. The one opposite the 30-degree angle is half of its hypotenuse. And of course, the one opposite the 60-degree angle is square root of 3. So like what I have mentioned, the ratio of 45, 45, 90-degree triangle is 1 is to 1 is to 2, to square root of 2. And then the ratio of the sides of a 30, 60, 90-degree triangle is 1 is to 2 is to square root of 3. So these are the 6 trigonometric functions, and they can be remembered through this, SOHCAHTOA and CHO-SHAKAW. So let's look at this triangle to know where hypotenuse, opposite, and adjacent sides are. So let's say this is theta. The one opposite to it, the side opposite to it is called opposite side, of course. And then this side is called adjacent side. And this side opposite the 90-degree angle is the hypotenuse. It is, in fact, the longest side. Now, we look at the sine theta, and it is equal to opposite over hypotenuse. And this is this part of SOHCAHTOA. Sine equals opposite over hypotenuse. So it's so easy to remember what sine theta is with SOHCAHTOA. The same with cosine theta. Cosine theta is equal to adjacent over hypotenuse. So if you notice, the cosine theta is the initial of, its initial is C, and the initial of its numerator and denominator are A and H respectively. So this is Ka. Cosine equals adjacent over hypotenuse. And then the TOA, of course, will be tangent is equal to opposite over adjacent. Now, the CHO-SHAKAW works the same way. That these are initials of the definition of cosecant, secant, cotangent. So, this one, you may also notice here the word flip. That means the sine and cosecant are related because if you, as you can see here, they are reciprocals of each other. The same way with cosine and secant, they are reciprocals also. And tangent, cotangent are reciprocals. Okay? So, you may just remember the first three, then don't forget which is paired up with sine, which is cosecant. Like it's reciprocal. That's what you call cosecant. Cosine is paired up with secant, then because they are reciprocals, the same way with tangent and cotangent. So let's apply these 6 trigonometric functions in this triangle. So the hypotenuse is 5 and the legs are 3 and 4, where 3 is the opposite side of the theta and 4 is the adjacent side of the theta. So we know that sine theta is equal to opposite over hypotenuse. So that would be the one opposite theta is 3 and its hypotenuse is 5, so 3/5. And then cosine theta is adjacent over hypotenuse. The adjacent side of theta is 4 over its hypotenuse 5, so 4/5. And then tangent theta is opposite over adjacent. That means the opposite side of theta is 3 over its adjacent side. That's 4, so 3/4. And of course, if we take the reciprocal of sine theta, that will be cosecant theta. Therefore, cosecant theta is equal to 5/3. And then cosine, when you take its reciprocal, that's the secant. And so from 4/5, if you make it 5/4, that's the value of secant theta. While tangent theta is opposite over adjacent. So you have 3/4. Take its reciprocal, it will be the same with cotangent theta. That is adjacent over opposite, so 4/3. So as you notice again, we may apply the SOHCAHTOA because of the initials. SOH, that's the SO. CAH, that's the ka. And then TOA, that's the TOA. The same thing applies for the next three. And then here is the special angles or special right triangles on the first quadrant. So imagine placing the 30, 60, 90-degree triangle on the first quadrant here. And here we see that this is the angle in standard position. Let us emphasize it here. So standard position, positive, it's going counterclockwise. And it ends with this terminal side. Okay? There. And this is the initial side. And of course, when you close it here, it becomes the 30, 60, 90-degree triangle. Now, let us relate the sides according to the ratio of the 30, 60, 90-degree triangle. Now, if you notice here, the 30-degree angle has an adjacent side of square root of 3/2. And the one opposite it is 1/2. And we expect this to be 1 because it's inside the unit circle. Since this is a unit circle, then we know that the radius of the circle is 1. And the radius of the circle overlaps with this hypotenuse. So this must also be 1. But if you remember a while ago in the ratio of 30, 60, 90-degree triangle, this hypotenuse is equal to 2. So let us relate the two. Is it really 2 or 1? Let's see. Now, if you remember, the 1:2 is to square root of 3 is the ratio of 30, 60, 90-degree triangle. Now, once this triangle is placed here as an angle in standard position, we need to adjust the hypotenuse that says 2. It has to be made 1 because it is placed inside the unit circle. Now, the question here is, if this part of the ratio 2 is the hypotenuse of the 30, 60, 90-degree triangle, at the same time, the radius of the unit circle, this part must be made 1. And so, how do we change 2 to 1? What do we do with 2? What can be applied to 2? What operation can be applied to 2 to make it 1? So, we divide 2 by 2 to make it equal to 1. Now, we are only allowed to do that provided that we also make changes with the other parts of the ratio, 1 and square root of 3. And it should be the same change that we do with the hypotenuse. So since we divided this by 2, we should also divide 1 by 2 and the square root of 3 by 2. In that way, we make adjustments with the ratio itself. So that's the very reason why the side here, which is opposite the 30-degree angle, becomes 1/2 instead of 1 here because of the adjustment that has to be made due to the placing of the special right triangle inside the unit circle. And then the one opposite the 60-degree triangle or the 60-degree angle becomes square root of 3/2 instead of just square root of 3. And of course, this hypotenuse, which used to be 2, becoming 1 because it's inside the unit circle. So now, this side of the triangle is square root of 3/2 long, and this side of the triangle is 1/2 unit long. Now, this point here corresponds to a point. This corresponds to a value of x and corresponds to a value of y. So what is x and what is y at this point? So if we base it from the distance here along x-axis, that's the x value. The x value of the point must be square root of 3 over 2 as shown. And then the distance with respect to the y-axis, the vertical side here, is 1/2. So that must be the y value here. That's why this point has coordinates square root of 3 over 2, 1/2, which is in fact called the terminal point. So this is a point found along the unit circle that intersect with the terminal side of the angle. So this is called terminal point. Now, if we identify the sine 30 degrees, this is the angle we're talking about, opposite over hypotenuse. So opposite 1/2 over hypotenuse. We know that the hypotenuse is 1 whole. So final answer is 1/2. That's the sine 30 degrees. And then the cosine 30 degrees is adjacent side, square root of 3 over 2 over the hypotenuse, which is also 1 whole. That's why final answer would still be square root of 3 over 2. Now, notice that these are parts in the coordinates of the terminal point. So the first one is the value of cosine, and the second one is the value of sine. So therefore, from the terminal point, we can already identify the values of cosine and sine respectively. Here, I need you to pause this video. Continue playing the video only when you are ready to check your work with the answer key in the next slide. Find the values of the 6 trigonometric functions of 60 degrees. Then write your answers in your math notebook. So this is the answer key. So we identify the terminal point, 1/2 square root of 3 over 2, which again, based from our discussion, cosine 60 degrees will be 1/2, and sine 60 degrees is square root of 3 over 2. Now let us verify this by highlighting this triangle formed by the 60-degree angle in standard position, as shown here, positive because it turns counterclockwise. And of course, this is the right angle, the 90-degree angle. And here is the 30 degrees. Now, based on what we know about the opposites of the angle, the opposite of 60 degree and the adjacent side, and its hypotenuse, and the adjustments that we have to make with the hypotenuse due to this side overlapping with the radius of the unit circle becoming 1. So this becomes the adjacent and the opposite side of 60 degrees instead of just 1 and square root of 3. So therefore, this is the distance with respect to the x-axis, and this is the distance with respect to the y-axis, which makes the terminal point 1/2 square root of 3 over 2. And further, we can say that sine 60 degrees is equal to opposite over hypotenuse. Opposite of 60 degrees is square root of 3 over 2. And we know that the hypotenuse of this triangle that overlaps with the radius is 1. So square root of 3 over 2 over 1 will be just square root of 3 over 2, which is again the same with the y value of the terminal point. Then the cosine 60 degrees adjacent over hypotenuse is equal to 1/2, which again found by taking the adjacent side 1/2 over the hypotenuse 1, which is just 1/2. And this one follows tangent 60 degrees opposite of 60 over adjacent. We cancel the 2, and so we get square root of 3. And of course, the next 3 are just reciprocals of the first 3. Cotangent 60 degrees is reciprocal of tangent 60 degrees, and secant 60 degrees is reciprocal of cosine. And then cosecant 60 degrees is reciprocal of sine 60 degrees. So here, we review that when there's a denominator that is in radical form, we multiply by square root of 3 over square root of 3 to rationalize. So we get this final answer, 2 square root of 3 over 3. And then 1 over square root of 3 is equal to the square root of 3 over 3. Okay, thank you, and I'll see you in the next LP.